Children learn two kinds of script in school. One is a phonetic script called kana. In kana, each symbol stands for a specific syllable. As language, it's processed in the left hemisphere. The other form of writing is called kanji. It's a pictorial system which is perceived visually. A single character can have several meanings and sounds. Because of its visual nature, kanji is processed at least partly in the right hemisphere. This is the symbol for sun, which the Japanese adopted from the Chinese around the 4th century AD. It's clearly pictorial, a right hemisphere specialty. Over time, the symbol changed. It began to lose its pictorial qualities. Today's symbol is angular, radically different from its original form, but it still conveys visual information and is probably processed mostly in the right hemisphere. Culture is an important factor in organizing the brain, and language is a crucial part of culture. Dr. Tadanobu Tsunoda maintains that the language a child learns influences the way the two hemispheres develop. He tested Japanese and Western subjects and found that the two groups seemed to process language differently. The Japanese process sounds like crying in the left hemisphere. Westerners process these sounds in the right.
日本人がこういう雨の音だとか、それから虫の音だとか。
The Japanese people are very sensitive to the sounds of nature, like the sound of rain, the sound of crickets, and the sounds of cicadas. To the Japanese, these sounds have meaning like words and are processed in the left hemisphere. Westerners treat these sounds as noise. The difference is that for the Japanese, these noise-like sounds have meaning. Therefore, though the sounds of nature don't have meaning, we Japanese treat them like language and process them in the left hemisphere. Westerners treat them as noise and process them in the right hemisphere.
Dr. Tsunoda's work has come under fire, but many agree with his basic idea, that culture has a biological effect on the way skills are organized in the brain. The Aborigines of Australia have survived the trackless wastes of the continent for centuries. To do so, they have developed extraordinary visuospatial skills, a feature of the right hemisphere. Has the combination of experience and evolution changed the way they think? Aboriginal children do not perform as well as white Australian children on conventional verbal tests. One psychologist, Judy Carnes, thought the tests might be ignoring the Aborigines' real skills.
The children I've found know a great deal more than I do, and a great deal more than most white Australian people. They take for granted that we possess most of the knowledge they have, and we don't. They think that a sense of direction is brought into everybody, for instance. And also, the same thing applies to all their knowledge about the wildlife of their region. They don't really seem to think that any of their knowledge is special, and it is very much so.
Dr. Carnes believes that Aboriginal children use their visual and spatial memories more than white children. She invented a game to test her theory. The task, to remember the positions of a set of objects on a board. The man-made object should be easier for verbally oriented children to remember, because natural objects are not as easily described and remembered in words. Carnes used both natural and man-made objects.
All right, open your eyes and see.
The most difficult group of all to describe verbally, 12 stones. Philomena has 30 seconds to memorize the positions of the stones. She can take as long as she likes to put them back.
Very good. Yep. And then almost all in the right places. That one's right, that one's right, that one's right, that one's right. So is that and that and that. That is. So these two should be swapped around. Do you think so? I've tested children between the ages of 6-something and about 16 years and a bit now. And they always perform better than white Australian children. Oh, and also the rate of superiority, if you like, stays about the same. They perform at about 3 years ahead of the white Australian children, so that an Aboriginal child of 7 years would perform about as well as a 10-year-old white Australian child. Not quite as well, but it's about a 3-year difference. They also tend to perform these tasks in even ways in terms of tempo. They don't hurry in and put a few back and then slow down. They seem to perform at the same rate all the time. And they also don't mutter or mumble, which a lot of white Australian children have done while they were viewing the tasks, I think in efforts to learn the names, hoping that that would help them to remember where the items went.
The two groups of children use different strategies and perhaps different parts of their brains to solve the puzzles. Culture is not the only influence on the brain's blueprint. In fact, there are differences more universal than those between Japanese and Westerners, Aborigine and white. We now know that there are important differences between the brains of the two basic groups that comprise humankind, males and females.
I think that evidence which exists suggests that women are on the average better verbally than men. On the other hand, there is evidence men have better spatial function. This doesn't mean that there aren't women who don't have absolutely superb spatial function, and there are plenty of men like myself whose spatial function is abysmal, clearly. So it doesn't come to you because you're a man, or it's not necessarily not there because you're a woman. We're simply talking about statistics.
The question of even minor statistical differences between men and women is a highly charged issue. Both sexes have strong feelings about the very idea, and the evidence is only beginning to emerge. Nevertheless, there are statistical differences. They exist, for example, in the senses, smell, hearing, and touch, as well as in hand preference. It's now thought that hand preference is affected by sex hormones during brain development. About 10% of males are left-handed, compared to only 4% of females. Left-handers actually respond differently to the world. They include a higher percentage of artists, architects, and athletes. And they suffer more learning disabilities like stuttering, autism, and dyslexia.
Well, if you go back and say to yourself, what is it that's altering the brain to make people left-handed or to make them dyslexic or stutterers and so on, you could then say, yes, we think that there is some chemical influence, very possibly male-related, possibly testosterone, which is altering the way the brain develops on the left side.
How do left-handers develop differently, and what is the effect of sex hormones? Every male fetus receives jolts of testosterone from the testes. Gershwin suspects left-handers receive more. This is testosterone. Does the extra dose slow brain development in the left hemisphere, shifting males from a right-handed pattern to a left-handed one? We don't know. But we do have evidence of the power of sex hormones to shape the brain and body. Rats, like humans, have divided brains. Using special techniques to freeze, slice, and measure the cortex, Professor Marion Diamond at the University of California at Berkeley has found structural differences between the two hemispheres. She has also found sex differences. Female brains have thicker left hemispheres. Males have thicker right hemispheres. To find out whether she could reverse this male-female pattern, Diamond manipulated the early hormonal environment.
We decided to take the ovaries out of the rats when they were first born, and then look at the right-left differences when the rats were young adults. And we found that the pattern had switched. Instead of having a large left hemisphere, we found a larger right hemisphere, very similar to the pattern in the male, especially in the visual spatial area.
Diamond also removed the testes of males at birth and found that the front two-thirds of the brain switched to a female pattern. In a second experiment, rats are exposed to 3 different environments: a barren, impoverished environment, a standard colony, and an enriched environment filled with toys and social contact. Could these environments actually have an effect on the size and shape of the cortex?
The results show that the enriched rat's brain is larger than the standard colony, and the impoverished rat's cortex actually is smaller than the standard colony. So in essence, with enrichment, the brain grows, and with impoverishment, it decreases in size. We find sex differences in the animals that have been exposed to the enriched environment. In the males, we find greater changes in their visual spatial areas. In the females, we find greater changes in their general sensory cortex.
By measuring the thickness of the cortex, Dr. Diamond can judge the effects of these environments. She has 2 consistent findings. Experience can change the cortex at any age, and there are sex differences in how the cortex responds.
We don't have too much hesitation in extrapolating our findings from rats to man, because brains are made of nerve cells, whether we're dealing with rats or men.
No one has identified differences in the anatomy of the human brain with such precision. But if experience affects the 2 sides of the brain differently, it may also account for some of the sex differences in humans. Caroline Smith is studying how we treat children. She asked mothers to play with children they have never met before.
He's 6 months, so he can't really sit up. So if you put him down on the floor, put a hand behind him to support him. But that's it. You can do what you like, where you like, 10 minutes.
Smith is analyzing the difference between mothers' reactions to girls and to boys.
What would you like to see? What would you like to see? Would you like to see that? Would you just like to say hello for a minute, would you? That's a funny noise, isn't it?
The toys the mothers offer the babies are influenced by the child's sex.
Hello. 1, 2, 3. Would you like to hold this for a minute? That's a nice smile. That's a nice smile. Would you like to sit on the floor for a minute? And you crawl. Are you going to start to crawl?
Boys are encouraged to be active, to explore their environment.
Here's the ball. There. That's right. You're getting there. A little bit further. That's it. You've got it. That's right. You've got it. What can you do with it? Off we come.
But sometimes the children are disguised.
Nice. Yeah. Look at